Namaskar and welcome. As we have already started our series of lectures on ANOVA, and we are with one more case of one-way classification. One-way classification means there is only one independent variable and there can be three or more levels of independent variable. Okay. And dependent variable is always performance. Let's read the question or problem. A manufacturing company wishes to test whether its three salesmen A, B and C tends to make sales at on an average same size or whether they differ in their selling ability. So average sales by the salesman is taken as his or her selling ability. So here the statistics of sales can be taken as dependent variable, and independent variable is sales ability of these three. Yes, and what is the criteria of sales ability? One is say non-numerical ability, but for that they have to make call. Yeah, sales during last week there have been 14 sales calls. A made 5 calls. See, in 5th call A failed in making any sales. B 4 calls and C 5 calls. Following are the weekly sales records of 3 salesmen. These are 15 sales records. Sales records, no, sorry, 15, no, 14, 5, 4, 5. I'm very sorry. Yeah, and this is actually for our calculation purposes. Test whether the average sales of the 3 salesmen differ significantly. Take alpha equals to 0.05. Okay, first of all, since the sales statistics are very large in thousands, by dividing the sales statistics by 1000, we have coded the data. Yeah, that will not affect our F ratio. Please don't worry. X1 is sales statistics made by A and coded by dividing by 1000. Similarly X2, X3. And as we know, we need squared values of all the statistics. So we have everything ready. Yeah. One important point I am going to discuss in this lecture, but later on at the time of discussing the hypothesis is about one-tailed and two-tailed. But let's first of all find out the required statistics or things. First we need T. T for grand total, nothing. Grand total of these three. T is sigma x1 plus sigma x2 plus sigma x3 and so on up to k number of times. Here it is 15 plus 16 plus 25. So it comes to 56. Another item we need is N. N means total number of units. 14 calls. So there are 14 units. But you can also see this thing in this way. Okay, yeah, we have to take number of units for A as 5 and not 4. Because A made 5 calls. Total number of sales efforts by A was 5. In the 5th, he or she failed. So there are total 14 units of sales efforts. Now we can find out the correction factor T square upon N. T square means 56 square, N is 14, so it comes to 224, sorry not 5, 4. Now SST, total sum of squares. I have already discussed the full forms of all these terms in the previous lectures. So in this and next few lectures we shall be directly writing, speaking, whatever you tell, the main title of the calculation only. SST. What is the formula of SST? This whole table is prepared for calculating SST. Sigma x1 square plus sigma x2 square plus sigma x3 square minus correction factor T square upon N. Yeah, actually the logic of calculating SST is summation of squared values of all the units. Yes, summation of squared values of all the units minus correction factor. To get this amount easily, ordered statistics rather. So it is 59 plus 70 plus 135 minus 224, that is 205 plus 59, 264 minus 224. So SST comes to 40. Now SSC, sum of squares for columns. Columns means sales efforts, independent variable. But these are the levels of independent variable. There is only one independent variable, sales ability of salesmen. There are number of salesmen means number of levels of independent variable. SSC, please be careful. Try to understand the difference between this sign and this sign. Sigma x1 the whole square, that means square of this value, divided by n1 plus sigma x2 the whole square divided by n2 plus sigma x3 the whole square divided by n3 minus correction factor t square upon n. That means 15 square divided by 5 plus 16 square divided by 4 plus 25 square divided by 5 minus 224. Yes, this will be cancelled against 15 by 3, this will be cancelled by 4, this will be cancelled by, 15 into 3, 45 plus 64 plus 125 minus 224. So ultimately it comes to 234 minus 224. 234 minus 224, that is 10, that is SSC. Now we have SSC, so we can directly calculate SSE, the shortcut. SSE equals to SST minus SSC, and that is 40 minus 10. So SSE comes to 30. So now we have everything, SST, SSC, SSE. We have number of levels of independent variable, there are number of columns. We have total number of units, everything we have, so we can prepare the ANOVA table. Let's prepare. Source of variation, yes, sum of squares, degrees of freedom, mean squares or mean sum of squares, yes, and the last will be F ratio, but I don't know about the width to be used. This one is say calls or sales efforts, but ultimately columns. SSC equals to 40. No, sorry, SSC equals to 10, not 40. Degrees of freedom. In case of this, degrees of freedom will be k number of columns minus 1. That is 3 minus 1 equals to 2. Then error. Error means residual. Because of the sampling fluctuations, you can say that. SSE. SSE we calculated is 30. For that, total number of units minus number of columns or number of levels of independent variable. It comes to 14 minus 3 equals to 11. Yeah. And total. Okay. Total will be equivalent to SST 40. Yes. This will be equivalent to n minus 1 That is 14 minus 1 equals to 13, and it is tallied 13. Okay. Now first will be MSC. That is SSC divided by K minus 1, and that is 10 divided by 2 equals to 5. MSE will be SSE divided by its relevant degree of freedom n minus k. You can write the sign C instead of k. That is total number of columns also. It is upon you. I write k because I always speak k number of populations, k number of samples, blah blah blah. K levels. Yes, 30 divided by 11. 30 divided by 11 comes to 2.73, but let me check. 30 divided by 11. Yes, 2.73. So now we can calculate F ratio. Calculated value of F will be there. F equals to MSC divided by MSE. That is 5 divided by 2.73. So F calculated will be 5 divided by 2.73, and that comes to 1.83. 1.83. So now we have two important things readily available from this ANOVA table, that is degrees of freedom, calculated value of F. So now we can perform the testing of hypothesis, and that is for significance of difference between the mean sales of three salesmen representing their sales ability. Let's write the null hypothesis. The selling ability of the three salesmen is almost same. That means there is no significant difference between the mean sales of the three salesmen. You can write in that way also, but this is, say, more relevant to the case. Yeah? Okay. Try to write the hypothesis, null hypothesis as well as alternative hypothesis in simple words but relevant to the theme of the question. It is very strange every time to write it in sign only, to write it in always the same kind of word. There is no significant difference between means, blah blah blah. It does not reflect your knowledge, your understanding about the thing. Because in practical life, we have to think the thing in this way only. Yes? Can you understand? So try to write the hypothesis in simple words but relevant to the theme of the question. I have seen many teachers writing the hypothesis in this way only. I don't think that is a good thing for a teacher or being a teacher. I should try to, say, express everything in more relevant way. And alternative hypothesis will be at least two salesmen differ significantly in their selling ability. What is the statistical meaning of this alternative hypothesis? At least two salesmen have no similar sales, or the average sales of at least two salesmen differ significantly. At least two means two or all the three. Now, important thing, Actually, in the last period, I somehow I forgot actually to discuss the thing. Every time, in case of any test, when we write and think about alternative hypothesis, we simultaneously think about whether the test is two-tailed or one-tailed. In this case, or say in case of ANOVA, what exactly is? Yeah, the test is always one-tailed. It sounds strange. The average sales of at least two salesmen differ significantly. That means at least two means differ significantly. Out of three here, at least two. That means any two or all the three. There is difference between sales of A and B or A and C or B and C or A, B and C, all the three. So far as one-tailed or two-tailed is concerned, what is the interpretation? Suppose sales of A and B are not equal. Average sales of A and B are not equal. What exactly can be there? Either S sales is greater than B sales, or S sales is less than the sales of B. That means not equal to sales of one is less or more than the other one. Now extend this logic to 3. Average sales of all the three are different and significantly different. That means sales of any one is greater than the other two, or two greater than the another third, blah blah blah. But ultimately there is always a direction. Sales of one level of independent variable, rather average or mean of one level of independent variable is more or less than the other two. That means ultimately it can always be concluded as one-tailed test. So don't worry in case of ANOVA about dividing the alpha by 2 and taking two critical values, because in case of F test we have to take two critical values, upper tail and lower tail. In case of ANOVA, don't worry. Okay? Yes. Let's move forward. HA is mu1 is not equal to mu2, mu2 is not equal to mu3, or mu1 is not equal to mu3, or all the three are different from each other, significantly different. Okay? Yeah. See, the sign is not equal to, but the sense is of one tail. So you just can remember only one thing. In case of ANOVA, one-way or two-way classification, the test is always on upper end. Yeah. In case of the graph, yes, the critical value is always here, acceptance region is there, and this is rejection region. Yes, always think of this kind of test whenever there is ANOVA. Okay, I think you are able to understand the thing. See, that's why we take only one critical value every time in case of ANOVA. Okay, now what? Yeah, degrees of freedom we have for denominator 11 and numerator 2. Critical value, alpha will be 0.05. Critical value of F for alpha 0.05 and degrees of freedom 11 to 2 is 3.98. 3.98. I have already explained how to find the critical value of F from the table more than once in my previous lectures. Now, the same thing, comparison of calculated value and critical value. F calculated is 1.83. F critical is 3.98. That means calculated value of F is less than the critical value. If calculated value of test statistic is less than critical value, the null hypothesis is accepted. We accept the null hypothesis and conclude that more or less the mean sales of the three salesmen are similar. The difference between the three average sales is not significant, or the selling ability of the three salesmen is almost same. I hope you are able to understand the whole thing, all steps of calculation, ANOVA table, etc. for one-way classification. If you like this lecture, please don't forget to click the like button, and also if you have not gone through my YouTube channel, you can go through and subscribe my YouTube channel. That's it. Thank you very much.